Okay. So the last type of inheritance we have, you don't need to take any notes because I'm going to give you the practice that goes with it, but it's called X-linked, but it's also called sex-linked inheritance. And the reason it's called sex-linked inheritance is because it's on the X chromosome. And so I pulled up this, you can leave it, don't try and follow me. I tried to pull up this, this pedigree, or the karyotype, so we can see this. So, and then I had it on the board too with regard to the size of the chromosome. So the Y is really, really tiny, okay? So we talked about this before. When you look at the chromosome sizes, the bigger they are, the more DNA they have, the more genes they have. So normally what happens is, we've been doing all the different crosses. So we'll say we have hair color, okay? Well, you have 2 chromosomes for every one of your autosomes, okay? The only thing we have different is we have the sex chromosomes, which are a little bit different than the autosomes. So because you have 2 chromosomes, you also have 2 alleles for every gene. So we'll say we'll go to gene number, or chromosome number 3. We'll say this little area right here is for hair color, and likewise the same exact spot over here is for hair color, and you've got 2 different alleles, whether you got 2 darks or 2 lights or whatever you have, you always get 2 alleles for every single trait that you have, okay? So when you move down to the sex chromosomes, here you have 2 different things that are going on. These are the things that determine your sex, okay? So we're going to determine sex with those chromosomes. But the other thing is too, when you have the alleles, because the Y is so small, it's small because it's missing DNA, it's missing alleles, okay? So let's do the same example here. For every one of these chromosomes, you'll say, here's a gene here, and here's the other allele here. You have an allele here, and you have an allele here. When you're down here, and I picked the boy one on purpose because we're missing alleles, if you have an allele here, you don't have an allele here. So as a boy, you're missing genes. As a boy, when you do this cross, what you're going to end up having is 1 allele for the 1 trait, and if you get the recessive one, it can't be masked by a dominant because you're only getting 1. If you're a girl, you have 2 X's, and then you have 2 alleles, okay? So that's how it mixes up. So basically what happens is, when you do the X-linked crosses, and I always try and make sure I say it right, it is X-linked because they're genes that are on the X chromosome, okay? One other thing, the reason the Y is called the Y, it's a weird story, but it has nothing to do with its shape, okay? Just know that. But so normally what we did is we said, here's your alleles, we got big D, little d, you set up your Punnett square, you do your probability, and you're good to go, okay? You have to do 2 things when you do an X-linked cross, okay? First thing is you say, all right, I got a girl, so she's going to be XX, and I have a boy, so I have XY. Set up your Punnett square, cross them like normal, XX, XX, XY, XY, right? So now when we talked about the probability of having a girl versus a boy, we always said it's 50-50, it's 50-50. You have a 1 in 2 chance of having either one. We're good to go with that? Okay. So now the weird thing is when you determine whatever trait it is, and the easiest thing about colorblindness, and this is actually the part of the unit where this is the last thing we've done. You've done all your other crosses normally, and you've done it however you've done it, and you've been able to distinguish between all that. And then we do this last cross, and this screws up like 10% of the kids. And now what they do is they do this type of cross with every single trait. With every single trait. And I go, it is only for the only real 2 examples that we use are for colorblindness and for something else called hemophilia. Hemophilia is a bleeding disorder, and what it is basically when you get a cut, you start bleeding, and platelets, which cause clotting, are released. So when you get a scab or when the bleeding stops, it's because enough platelets will rush that area to stop the bleeding. So if you're a hemophiliac, what that does is the platelets aren't created, and you just keep bleeding. You just keep bleeding. One of like a minor example of what would happen is somebody who has hemophilia, they'll tend to get like really, really big bruises. Because a bruise, or what they call a contusion, is basically a cut under your skin. So if a simple bump, they'll just have this giant bruise because it just keeps bleeding and bleeding and bleeding. So what do they have to do? Normally what those people have to do is they have to go to the hospital, they have to get an infusion of platelets to help them stop bleeding so that they don't die from a simple cut. You follow me? Okay. So my point is this. With humans and the type of crosses that you're typically going to do, so normally you went like this. When you did your crosses and you looked, you go, all right, we have normal dominance because it says dominant recessive. We found out that there's a blending of the trait, therefore it's incomplete dominance, or both of them are expressed, we have co-dominance. The way that you figure out whether you're going to do this type of cross, an X-linked cross, is the 2 things are going to be, is it hemophilia or colorblindness? Those are only 2 human ones that we ever do, okay? So there are a couple of incidences where there's, so on the Y chromosome, it is missing genes, but there are genes on there. and they do code for certain things, but it's all boy-related stuff. And there's only about 30 genes that are on the Y chromosome. One of the genes that's on the Y only, which is why guys only get this gene, is for ear hair. Okay, so guys, as you get older and older, you'll have this bush. Look at your grandpa; there's a bush of hair growing out of their ear. Okay, that's because the allele for it is only on the Y chromosome. Okay, so go back to this. So when we do our X-linked thing, part of the cross is to do XX and XY. The other part is to figure out what the alleles are. So we'll use color blindness. Color blindness is recessive. So I'm going to do capital C is normal, and then we know color blindness is recessive. All right? We're going to cross a colorblind male with a normal, homozygous normal female. Okay? So what you do here is the female is capital C, capital C. You do it superscript like that. Because the male is colorblind, you put the little c on here, and there you just don't put anything on the Y, because there is no alleles on the Y. Okay? So when you go do your cross, you have X big C, X little c, X big C, X little c, and you come down here, X big C, X big C, and you're done. Make sense? Okay. So it's kind of a two-part cross. Now the best part about this is you're able to see how these genes are moved along, especially with X-linked. Okay. So this is why earlier in the semester when we talked about the person in our class, I don't want to say their name because it's going on YouTube, the person in our class who has color blindness, when I said, look, if you have it, you won't give it to your sons, okay? Only thing a guy does with X-linked traits is they donate the Y, and they contribute the Y to make them a boy. But they don't contribute any X-linked traits, okay? Where do the X-linked traits go? To the daughters. And the daughters will pass it on to who, okay? So we'll take this to the next step. So we'll say, we'll take one of these individuals, all right? And we'll say she is crossed. We'll say she's X big C, X little c. So we're still carrying over, because it's an excellent cross, we're still carrying over the X, but we're going to cross her with a normal male, normal vision male. Okay, so we have X big C, X big C, X big C, X little c, X big C, Y, X little c, Y. So the questions that usually come along with these types of crosses is you understanding that the girl passes on the alleles. The girl passes on the alleles. And the alleles that get passed on by the guys go to the daughters and then eventually go to the sons. So if we track this one allele here, who ended up ultimately getting it? The daughter did, but who ended up getting color blindness because of the allele? Her son. Well, the grandkid, yeah, but son of the daughter. So it goes boy, this goes boy to daughter to the son again, and it keeps traveling like that. That's why I said if you make those predictions, you can look at it, and now you did not get the allele from your dad. The only thing that you got from your dad was this Y chromosome, right? Where did you get your color blindness from? You got it from your mom. Where did your mom get it from? You got it from her grandpa, and it keeps going back. Which is why if you go to your mom's side of the family, to her dad, he's colorblind, okay? Which sometimes people go, I didn't know that, or I don't know it. It has to be. The only other explanation would be there was some sort of mutation that happened. But this is one of those weird traits where it goes back and forth. So keep this in mind. When you do the crosses normally, do the normal evaluation. Is it normal dominance, incomplete, codominance, or is there a color blindness or hemophilia aspect? That's literally all you have to do. If you have those, this is what we're doing, okay? But one of the classic questions says, here, we'll do this. What would be the genotype of a color, here, ready? What would be the genotype of a colorblind male? Just write on your bell work or something like that. What would be the genotype of a colorblind male? And I'm going to pass this back out and work on it in a minute. It's a crazy question. It's super hard for some people and super easy for other people. So what would be the genotype of a color, we're using the allele C, what would be the genotype of a colorblind male whose dad was colorblind? Don't shout it out. What would be the genotype of a colorblind male whose dad was colorblind? Ten more seconds. You don't even have to do a cross. You just have to tell me a genotype. That's all I asked for. Genotype of a colorblind male whose dad was colorblind. right, so it's a trick question in a way. How many alleles does the boy get for the X for the X linked? Only gets one. So if I say you're colorblind, what is your genotype? X little CY. And then you go, yeah, but you said his dad's colorblind. What did he get from his dad? He got the Y only. It doesn't matter what his dad had. You follow me?
Yeah.
Okay. Okay. We'll work on it a little bit. Okay. Stay classy. Signing off.